In this lesson, you'll learn to find the sum, difference, product, and quotient of functions and find the composition of functions. Why is it important to combine functions in business? Carol Kaufman owns a garden store where she sells birdhouses. The revenue from the sale of a birdhouse is given by R of x equals 125x. The function for the cost of making the birdhouses is given by C of x equals 65x plus 5,400. Her profit P is revenue minus cost, or P equals R minus C. So the profit function P of x can be defined as P of x equals R minus C of x. If you have two functions, you can form a new function by performing arithmetic operations on them. Let f of x and g of x be any two functions. You can add, subtract, multiply, and divide functions according to the following rules. They have defined f plus g of x as f of x plus g of x, so just add, combine like terms. The difference, f minus g of x, you subtract and combine like terms. Product, f times g of x is the same as f of x times g of x. You're going to use the distributive property. And quotient, f divided by g of x is the same as f of x divided by g of x, where g of x cannot equal 0. Given f of x equals 3x squared plus 7x and g of x equals 2x squared minus x minus 1, find f plus g of x. So we just need to combine our like terms. 3x squared plus 2x squared would be 5x squared. 7x minus 1x is 6x. And the 1 didn't have a friend, so it just stays minus 1. Again, we just need to combine our likes. So 3x squared minus 2x squared would be 1x squared, and we don't normally write the 1. 7x minus negative 1x, 7 minus negative 1 is the same as plus 1. And minus negative 1 is going to be the same as plus 1 also. So we're going to end up with x squared plus 8x plus 1. Next, we'll look at multiplying and dividing. So if we have f of x equals 3x minus 2x plus 1 and g of x equals x minus 4, and we want to find the product, we're going to distribute. So we'll have 3x cubed minus 12x squared minus 2x squared plus 8x. And then plus x minus 4. We combine our like terms. We have 3x cubed minus 14x squared plus 9x minus 4. So it's a bit of a review on using the distributive property. And to do the quotient, we could just very simply write 3x squared minus 2x plus 1 divided by x minus 4, where x cannot equal 4 because I had to give us division by 0. We could go the extra mile and divide that out. So we'd have, bring down our 3, multiply 3 times 4 is 12, and we get 10. 4 times 10 is 40, so we get a remainder of 41. So we'd have 3x plus 10 plus 41 over x minus 4. There's a little dichotomy in the book. In the example in the book, they stop there. In the back of the book, in the problem sets, they go ahead and divide it out. Functions can also be combined using composition of functions. In a composition, a function is performed, and then a second function is performed on the result of the first function. The composition of f and g is denoted by f of g. This is read of. Suppose f and g are functions such that the range of g is a subset of the domain of f. Then the composition f of g can be described by the equation, and these are both read, f of g of x. The composition of functions can be shown by mappings. Suppose f equals 3, 4, 2, 3, negative 5, 0, and g equals 3, negative 5, 4, 3, 0, 2. The composition of these functions is shown below. Okay, so if we wanted to find f of g, we start with, in f, we had a 3. The composition of functions can be shown by mappings. Suppose f equals 3, 4, 2, 3, negative 5, 0, and the g function is 3, negative 5, 4, 3, 0, 2. The composition of these functions is shown below. And I kind of prefer this notation. This would be read f of g of 3. So I'm going to start with g of 3 is negative 5. And then I want to do f of negative 5. So f of negative 5 is 0. If we do f of g of 4, g of 4 is 3. There we go to 3. And then I want to find f of 3. That's going to be 4. To evaluate f of g of 0 is 2, and f of 2 is 3. So they write the answer with the ordered pairs. This is what we started with, and this is what we ended with, beginning, end. Now we're going to start with the other way around, do g of f of 3. So f of 3 is 4, g of 4 is 3. So that's how they get from 3 through 4 back to 3. So the ordered pair is 3, 3. To do g of f of 2, looking at the f function, if we put in 2, we get out a 3. So then we just need to evaluate g of 3, and we're going to get out negative 5. G of f of negative 5, f of negative 5 is 0, so then we want to do g of 0. Looking at the g function, if we put in a 0, we get out a 2. And again, they wrote their ordered pairs going from beginning to end. Now you don't need to write out all these business when you do it, but I was just trying to show you where it all comes from. Now in that example, we could go both ways for all of our numbers, but the composition of two functions may not exist. Given two functions f and g, f of g of x is defined only if the range of g of x is a subset of the domain of f of x. Similarly, g of f of x is defined only if the range of f of x is a subset of the domain of g of x. Hey, I'm probably going to write more work than I would normally do when I did this myself, but hopefully you can see where it comes from. I'm going to start off with f of g of 7. So g of 7 is 0. So that means I need to do f of 0. And when I look at the f function, f of 0 is negative 1. To evaluate f of g of negative 1, g of negative 1 is 7. So now I need to go over to my f function. F of 7 is 7. G of 4 is 9. F of 9 is 4. G of 8 is 2, and f of 2 is 6. Okay, now doing g of f of 2 is 6. So then we need to do g of 6. And here we have our little oops that we said we could have. The g function does not have a 6. But moving on, f of 9 is 4, g of 4 is 9. F of 7 is 7, and g of 7 is 0. Okay, g of f of 0 is negative 1, and g of negative 1 is 7. And so this we're only going to get 3 ordered pairs on the g of f, and we had 4 ordered pairs on the f of g of x. And they want us to find f of g of x and g of f of x for f of x equals 3x squared minus x plus 4, and g of x equals 2x minus 1. When we do the f of g of x, the f function is our structure, and where there was an x, we're going to replace it with g of x. So we're going to put in the 2x minus 1. So all that's left to do is simplify it. We square a binomial. We have 4x squared minus 4x plus 1 minus 2x, distribute the negative, plus 1 plus 4. So we get 12x squared minus 12x plus 3 minus 2x plus 5. So we have 12x squared minus 14x plus 8. Good to know that the g function is simpler, so that's our structure now. So we just need to substitute in the f of x in place of x and distribute Combine our like terms, and we have 2x squared minus 2x plus 7. Seemed like a good time to point out that in most instances, f of g does not equal g of f of x. Therefore, order in which you compose two functions is very important. Since they made us find the composition, it's no big deal to find f of g of negative 2 now. So we do 12 times negative 2 squared minus 14 times negative 2 plus 8. So 12 times 4 is 48 plus 28 plus 8 adds up to 84. Now to do g of f of negative 2, where there was an x, we're going to put a negative 2. Negative 2 squared is 4, times 6 is 24. Negative times negative is positive. 28 plus 7 is 35. So not too bad. Tracy Long has $100 deducted from every paycheck for retirement. She can have this deduction taken before state taxes are applied, which reduces her taxable income. Her state income tax is 4%. If Tracy earns $1,500 every pay period, find the difference in her net income if she has the retirement deduction taken before or after state taxes. They let x equal her income per paycheck, r of x her income after the deduction for retirement, and t of x her income after tax. So 100 is deducted for retirement. That means r of x is going to equal x minus 100, and the tax rate is 4%. So t of x equals x minus 0.04. If Tracy has her retirement deducted before taxes, then her net income can be represented by t of r of 1,500. Well, r of 1,500 is just 1,400. So now we use the t function, and we want 1,400 minus 4% of 1,400. And we get $1,344. If Tracy has her retirement deducted after taxes, then her net income will be represented by r of t of 1,500. So first we need to do t of 1,500, which would be 1,500 minus 60. And then we do r of that amount. So all we have to do is take 1,400 minus 100, and she's left with $1,340. So there is a difference of $4. And the answer makes sense. Since the taxes are being applied to a smaller amount, less taxes will be deducted from her paycheck. This lesson we looked at how to add, subtract, multiply, divide, and compose functions.